why is sex female chosen as the reference variable and not sex male? This is totally up to the discretion of R Studio. So R has taken, or in other words, the linear regression model inbuilt function has chosen sex female as the reference variable in this case. So BMI has a value of 339.3. What does it signify? For every unit increase in BMI, say my BMI is 24.3, and if it increases to 25.3, I have to my medical expenses will be 339 or approximately $340 more. Similarly, more the number of children I have, more will be the medical expenses. Let's say that I have 2 children right now. If I have a third child, then the medical expenses will increase by 475.7 or approximately $476. So smoker yes is also a dummy variable. As you can see on the screen, we have given only smoker as input. So smoker yes and smoker no are dummy variables created for normalization purpose by the linear regression model. So relative or with reference to smoker no, the cost will be 23,847.5 or approximately $23,848 more. That is, if a person smokes, he or she has medical expenses which is $23,848, approximately more than that of a person who does not smoke. Similar concept is applicable for the dummy variables region northwest, region southeast, and region southwest. As you can see on the screen, we have given only region as input. Hence, it's quite obvious that region northwest, region southeast, region southwest are dummy variables. Here, the linear regression model inbuilt function has chosen region northeast as the reference variable. So if a person belongs to the region northwest, then he or she has to will have medical expenses which are 352.8 or approximately 353 US dollars less than that of a person from the northeast region. Similarly, if a person comes from the southeast region, then he or she will have medical expenses which is 1035.6 or $1036 approximately lesser than a person from northeast region. And the same goes for region southwest. If a person comes from southwest region, he or she will have medical expenses which will be 959.3 or approximately $959 lesser than a person from the northeast region. So when we speak about a particular variable's beta coefficient, we assume that the other variables are constant. That is, only the variable whose beta coefficient is under discussion varies and the remaining don't vary. So this slide contains whatever we discussed just now. Y-intercept is not required because it is a constant, and it will be significant only when the values x1, x2, x3 dot till xn. Here till x6 becomes 0, which is impossible in this case. So we now understand what beta coefficients are. So if we substitute these beta coefficients in this equation, we will be able to predict the expenses of a new patient based on the values x1, x2, x3, x4, x5 and x6, which are nothing but the values for age, children, BMI, sex, smoker and region. Here for example, let's take that a new person comes in with age say 20, sex male, BMI some 25, children 1, smoker no, region southeast. We can predict the expenses using this equation. Okay, the remaining 3 points in this slide are already discussed. So we have given 6 variables as input, that is 6 independent variables, but we have got 8 variables. Of course, it's because of the dummy variables created. You can see we have given only 6 variables as input: age, sex, BMI, children, smoker and region. That is the independent variables. But we have got sex male, smoker yes, region northwest, region southeast, region southwest, etc., which are dummy variables. Dummy variables will be created in order to normalize data, and here in the case of categorical, particularly nominal variables. So having created the linear regression model, now let's see what does each dummy variable mean. For instance, let's take the variable sex. Sex male and sex female are 2 dummy variables that will be created by R. Why? Because sex is a categorical variable, particularly a nominal variable. So if the input is female, then sex female will be assigned the value 1 and sex male will be assigned the value 0. If the input is male, then sex male will be assigned the value 1 and sex female will be assigned the value 0. To tell it simply or in simple terms, the dummy variable's value will be marked as 1 if the condition is yes, else it will be marked as 0. So if the input is male, then sex male is correct. The condition is yes, hence it is 1. Obviously, sex female, for sex female, the condition is false. That is, the sex is not female. Hence, the value will be 0. Similarly, for smoker, we will have 2 dummy variables, smoker yes and smoker no. If the value or input given is yes, then smoker yes will be assigned the value 1. If the value given as input is no for smoker, then the dummy variable smoker no will be given the value 1. Likewise, for region, we will have 4 dummy variables: region northwest, region northeast, region southwest, and region southeast. If the region is southwest, then region southwest will be assigned the value 1. Likewise, If the region given as input is southeast, then the dummy variable region southeast will be given the value 1, and so on for the other two variables too. So that is what has been discussed in this slide. Okay, we have discussed till this slide. So what can we infer from these slides? Sorry, infer from this output. So if you see smoker, for example, smoker, yes, the value is very high. That is 23,847.5. I'm just taking an example. Hence, if you smoke, your medical expenses will increase by $23,847.5, and hence your insurance premium too will increase significantly. Hence, it is advised not to smoke. This is just one inference that we can draw. Like that, we can draw other inferences too. So now we are moving on to the next step. So which is evaluating model performance. We have created the linear regression model and we have inferred a lot from the beta coefficients. In simple terms, we have studied the relationship between the dependent and each of the independent variables. But we need to know how well this model fits our data. That is, to what extent is the prediction of this model correct. For that, we have to use the summary function. As you can see on the screen, the summary function gives us a lot of information than simply executing the ins underscore model variable. It contains residuals, coefficients, and adjusted R squared value. So what do residuals mean? We will look at each one by one. Residuals mean the difference or error of the predicted value compared to the actual value. So minimum is 11,300 minus 11,302.7. So which means that we have at least one value where the expenses is deviated or it differs by $11,302.7. Also, we have a maximum value of 29,981.7. What does this mean? We have at least one case where the expenses predicted are varies by $29,981.7. We can also see that 50% of the values lie between the first quartile and third quartile. Here we don't have the mean or average value, and hence we can assume that the values 50% of the values lie between first and third quartile. That is 50% of the values vary in the range $2,850.9 to $1,383.9, of course from minus to plus. Then coming to the second one, under coefficients, The values in the column estimate are nothing but the beta coefficients which we saw earlier. These coefficients. For example, if you take age, the value is 256.8. If you take age, the value is 256.8. So in addition to this column, we have got several other data. So we have stars at the end. So what do these stars mean? 3 stars means statistically significant. That is, this variable will have a significant impact on the expenses that we are going to predict. So this model says that intercept is a statistically significant variable, but as we have discussed earlier, intercept has no significance in our case study as it is a constant and a case where all independent variables are zero is not possible. Hence, we can ignore intercept. Let's see what are all the other variables which are statistically significant. That is the other variables that have 3 stars. We have age, we have BMI, we have children, and we have smoker S. So from this model, we can infer that age, BMI, children, and smoker are statistically significant variables or variables which greatly influence the expenses. Since we know that all the variables are positively correlated from the output of the correlation matrix, this one. So it means that age, BMI, children, and smoker will result in a significant increase in the expenses when there is a unit increase in each one of them, assuming other variables are constant. We have one more thing to be looked at here, which is nothing but the adjusted R squared value. It is 0.7494. What does this mean? 74.94% or approximately 75% is the accuracy of this model. This model, this linear regression, the linear regression model for this case study or for this random sample data can predict 75% of the variances in medical expenses. In simple terms, this model will be 75% correct in terms of predicting the medical expenses. Sorry, 75%. 74.94 can be taken as 75. So 75% is actually a good value, but we can try to look for better values. That is, we can try adjusting the model by including enhanced or improved variables in order to increase the accuracy of this model. So for doing this, we need domain knowledge of this particular industry. So let's assume that I have good domain knowledge about healthcare industry and specifically about health insurance. So I know that the variable age varies exponentially after a particular point. So let's take an example of an aged person in our home. So until our grandfather reaches the age of say 60 or 65, his medical expenses won't be that much. But once he crosses the age 60 or 65, his medical expenses will increase exponentially. So instead of using the variable age, we can use the variable